Good morning, one and all. I'm Praveen, and today I'm going to build and demo a real inventory management system that can handle the concurrency orders. So this is the exact problem companies like Amazon, Flipkart, and BookMyShow, like movie ticket booking applications, are using to handle the concurrent orders. So without any delay, let's go into the objective and prerequisites, and along with that concepts related to this concurrency ordering. I'll show you one by one. So this is the project I need to build a database concurrency control simulator for inventory management. So there are mainly two strategies in this project. One is pessimistic locking and optimistic locking. So pessimistic locking in a nutshell is lock the row first and do your work. And coming to the optimistic locking, do your work and update the row if someone else changed that. It will use something like a version and another thing. I will show you later. So now we'll be getting into example of this project. I'll show you the with explanation. So this is the normal transaction, two concurrent transaction trying to read the and update the same data at the same time. So coming to the first transaction A, it reads a stock equal to 100 rupees, not 100 rupees, 100 quantity. Uh, for example, two users are trying to order something from Amazon and reads a stock 100, and both read the transaction at time to T to 100. So transaction A is trying to make an order so that the stock becomes 90, and stock will be written as 90 on the Amazon side. So transaction B at the same time also trying to write the data to 90, which means they are ordering 10 quantity, so that write the stock 90. So what happening, this is called lost update problem. Both trying to read the same data and trying to reading the same data and writing the same data. Actually, what it has to happen, total stock need to be 80, but total stock is still 90. So this is not the good thing. So this is the same called race condition when in databases when two concurrent orders trying to access the data at the same time, at the same data at the same exact time. So coming to the pessimistic locking, I already told you what do you mean by pessimistic locking. Locks the row first and then do your work. So here at time t1 transaction E selects for update. So in PostgreSQL we will use the select for update. Read stock equal to 100. Okay, and transaction B select for update waiting, because why? Because transaction A is reading the data of and read the data stock equal to 100. So they make an order of 10, the stock becomes 90. Writing is completed, commit is released. So that once the lock is acquired, read the stock equal to 90 and the stock equal to 80. I mean, they ordered 10 quantity. So this is correct way and committed to the database. Next, coming to the optimistic locking. This is something different from the pessimistic locking. It what it will say is conflict is rare, so that I'll use the version and update when someone else changed it. So read the data stock equal to 100 version 1 at the version 1, and both transaction B also trying to read the stock equal to 100 and version equal to 1. So when both are at the same time, transaction A writes the data and one row affected, so the version becomes 2. But when it comes to the transaction B, they are also trying to read that and write that, but conflict detected, so that they need to retrieve from the step 1. So again, what it they will be seeing, so the version becomes 2, and then they will update the data. Okay, next coming to the database schema. So I have created two tables, mainly products and orders, and some seed data at the start of the container, so that they will be used for testing purpose only. You can use anything. So create table if not exists products. What it will be doing, it will be creating a table products if not existed in the database. So that what if we write create table products? So every time startup, it will be creating a table, so that table already exists error will occur. Coming to the attributes ID, which is of type serial. In MySQL, we'll use the auto increment, so that it will auto increment the ID one by one. So, for example, product has been inserted, product one, and another thing inserted, product two. So we set the ID as the primary key, so that unique values only inserted, and name of the product, varchar data type, and we ensure that it is not a null variable, and stock integer, because stock can't be decimal, so we set the data type to integer. And also we have added in check constraint, so that the stock will always be greater than equal to 0. Here we set this because in application code somewhere tries to read the stock. If it goes to negative, it is not a good condition, so this is also an security constraint. And version, as I already told you, for optimistic locking, we will use the version, so which is of integer type, not null, and default it will be 1. Whenever a change has been occurred, the version will be incremented to 2, like that. So another thing, once the products table has been completed, orders table. Here also same, order ID, serial, which is auto increment. In PostgreSQL, we will use serial data type, which means auto increment, and primary key, which will be used for only unique values, and product ID, which is of type integer, not null, references the products of ID. So this is like a foreign key in MySQL. And quantity order, user ID, and status. What do I mean by status? Failed, out of stock, or order success, like that. We create a status and created it. For example, at which time the time has been order has been placed, like that. So these are the some seed products. I mean, they are used for testing purpose only. So whenever we reset the database, only these products will be occur. So this is just for testing purpose only. Okay, let me show you the GitHub URL, and later we'll test with that. So it is an inventory API locking demo application. Tech stack I have used it for the building this application is, one is FastAPI. It is an asynchronous Python web framework useful for developing asynchronous applications, and PostgreSQL 15. It is in Docker image I have used, and async PG. It is in driver for application, driver application, which means our Python code will talk to the database, so that we need a driver between them, so that async PG, and Docker Compose for containerizing the application. So project goal means simulate high contention ordering and compare two concurrency control strategies. One is pessimistic, and another was the optimistic. So that's it. Okay, I have already explained about the products database schema. And coming to the API endpoints, this application need to build using REST API endpoints. So get, which is health will be used for health check, and slash API slash products ID to get the product details by ID, and reset. And pessimistic lock means places order with the pessimistic locking, and optimistic means same with optimistic locking. Stats for getting the statistics, I mean how many orders has been successfully completed, and if there are any conflict, and how many are failed, like that. So getting an order by ID for so these are nothing but an example. Okay, let's see the visual diagram at first theory. Pessimistic, it sees a transaction and locks the row. and so that another transaction trying to read the same data cannot be able to write the data. So reads the product using product row using select for update. This is used in PostgreSQL syntax. Checks the stock and writes order or status automatically. If the row log cannot be acquired within the configured timeout, the request returns a graceful conflict response. So we have also added a timeout. I will show you the later. And optimistic. Coming to the optimistic, it starts a transaction, reads the stock and version, and attempts update where ID equal to placeholder and version equal to placeholder. Why we have used placeholder means to avoid SQL injection, and retrace with exponential backup on conflict. I will show you that also. So strategy comparison. Coming to the diagram, visual representation of both of these. That's right. Okay, coming to the optimistic locking. So it reads a version and attempt update with version check. So no, okay, let's first see the pessimistic and it will be helpful. So acquire lock. So when both transactions trying to read the same data, we acquire lock on the first one so that they can read or modify the data and release lock. So then only another person will be able to use it. So I think there is a problem. Why is not showing? Let me refresh this. Yeah. Okay. So block other transactions meanwhile and ensure no conflicts. Coming to the optimistic, reads a version and attempt update with version check. So if version matches, it succeeds. If version change, retry with backup. I mean the it will be retry. So it will be higher concurrency. So need retry logic. And coming to the concurrent tests, it works well with one request. So what this application want to see, this application wants to test with concurrent requests, so that we have created a concurrent test dot shell script file. So in that I have created 20 plus requests, so that we'll see and monitor logs. So how logging is applying for the database. So we'll see this in the monitor logs.sh file, and later with the testing the endpoints. Okay, let's see the okay, database completed. And compose file, docker compose file is useful for containing building containers. So version, and coming to the services, there are mainly two services. One is database and another one is the our app service. So database, I have already mentioned I have used the PostgreSQL. So that instead of building the custom database, I have used the Postgres image, which will be taken from the Docker Hub. So environment, this will be passed inside the Docker containers, Postgres user and all the things, and running on the port numbers 543 to 5432. One is the host port and another was the container port. So that's it. And coming to the app service also, it running on the 8080 port, and it's depends on the database condition. If it is running and ready to accept invitations, then only app will be started. Otherwise, app will be started and waiting for the database. It wouldn't start, so app crashes. So that's why use the condition depends on database condition service healthy. So we'll see. First, the configuration file. Uh, config.py is nothing but to configure the environmental variables. So we have load.env from .env module. So it will be used for obtaining the env variables values from the .env file. And coming to the database.py. So this is nothing but as I told you, async PG will be used for it acts as a driver between our Python code and our database PostgreSQL. So async pg, it's an driver. Logging, logging is nothing but simply instead of writing printing the outputs errors, we will use logging. So in logging it, there will be levels, debug, info, warning, error, it will be divided. So in production systems there will be log aggregators, so each type of log will be aggregated into different types, they will be stored, so that we will use logging. And database url we have told you. So instead of you simply printing the manual error outputs, we use logging. So logger equal to logging dot get logger of underscore underscore name means this is the file name is coming from app database. So the name will be app colon database, and type of the async pg we have creating a pool instead of for every request do we don't need to make a connection with the database. So instead we created a pool where we can establish connections, so time will be saved. So I have created a method create pool. This will be creating a pool, async pg connection pool, which one can be accessed globally. Instead of creating the pool locally, what it will be happen once the function execution completed, the pool will be closed. So for that purpose, we have created the pool globally. Okay, you can check all the source code in the GitHub link. It is not possible to explain every line in this video. I will explain the important concepts. We have completed that. And main.py is mainly for our API endpoints. So orders and products. So as a part of FastAPI, it will use the pedantic validation. So whenever the request is not in the correct format, it will checks the JSON format exactly, so that there will be no malformed JSONs. Product ID is in the field greater than or equal to 0, GT equal to 0 means, and the quantity and user ID. So it is an whenever the request is in the pessimistic, we'll created the router dot post pessimistic. So I created a router, which means instead of writing for every method, I have created API router. So for every, how to say, instead of writing at the top of methods, we can use the API router. So it places this method places an order using pessimistic locking. So we acquire a row level lock before checking or modifying stock. And order stats means we will get the all the statistics of the orders. I mean, what are the successful orders, what are the failure orders, and what are the orders which are failed due to out of stock. So for all the API endpoints, I have written code here, and same way for products too. Yeah, API router is a mini application that groups related endpoints. Coming to the pessimistic and optimistic, these are the two main services in our application. Yeah, I forgot to tell you. Yeah, when creating a database pool, we need to ensure the minimum and maximum size. I mean connections. So minimum connections will be 2 and maximum will be 10. And retry. So whenever we will be applying optimistic, we will use the retrace. So maximum retrace equal to 3 and back of equal to 50. I mean 50 seconds. So first request it has to retrieve for 50 seconds, and second request it has to wait for 100 seconds, and third request it has to wait for 150 seconds, like that. And pessimistic logic is for every 2 seconds the PostgreSQL will update the data. So 2000 milliseconds in seconds will be 2 seconds. Coming to the pessimistic logging, yeah, we'll be checking if the product, I mean if the stock of the product is less than quantity, we'll print the optimal inefficient stock. Pessimistic lock mainly works in the like select for update, and optimistic will be using version number. So this is a high level definition flow for attempt. Begin the transaction. Read product. I mean, we'll be reading the stock and how much quantity is present, and version. If no products, value error. If inefficient stock, insert failed out of stock, return fail, and try update where ID equal to placeholder and version equal to placeholder. If row count equal to one, success inserts success order, return. So like that, it will be working. Okay, let's test with the endpoints. So let me see whether Docker is running or not. Yeah, inventory API is running. So first, we'll be checking the health check, whether the container is running or not. Not container, our Python application, we have written the health check condition. Okay, in PowerShell, curl will not be working. So instead, we will use the git bash. For PowerShell, we need to use the invoke minus URI. So in curl, we can use the git bash. So yeah, status is 8080 is running. You can also manual check. Yeah, docs. We have got that. And coming to the health, yeah, status okay means everything is running perfectly. So FastAPI inbuilt it comes with the OpenAI and OpenAPI and Swagger UI, so that we need to work easily and interacting with the API endpoints at here itself. So, but we'll use the curl comments. So coming to the products of one, yeah. Why they are coming with super widget and stock 100 version? Because for testing purpose, we have created two products. Let me show you. So at the start of the containers, they will be showing them, and if all the products are reset, they will be getting these only. Let's check with the product slash two. Yeah, mega widget, mega gadget, and stock 50 version number one. So these only come when all the products are reset. Okay, reset inventory means we haven't created any orders, but anyway, just create reset the inventory. What it will does, it will simply removes all the products if anything is inserted. So yeah, product inverted reset successfully. You can check out the method for the reset. It will be using slash reset endpoint, which is a post request and resets all products to their initial seed state. Use it for testing only. I have already told you. Okay, let's test with the pessimistic and optimistic orders. Yeah, this is a single request. We don't need to see any concurrency effects. So order ID 46 and product ID 1.